And we are once again live from downtown Mill Bay. Are we? Connect streaming software. Yes, we are. Five, four, three. Oh, 55. Okay. Last section that we're going to do before the cross grade, and that is the 6 different types of reactions. Apparently my clock is faster than the bells. So I'm going to list all 6, and we're going to go through them one by one. Now that you have all of the nomenclature and you've done all of reactions, we picked these 6 because they're very good at this level of chemistry for allowing you to predict the products. So from only the reactants, you should be able to predict what type of reaction it is, and then be able to predict the type of products. And it puts everything together. There is, especially if you go into biochemistry, 100 different ways of doing different types of reactions, whether you do reaction mechanism, where the electrons go, and a host of other things. But these are fundamentally in terms of what they look like and for being able to predict the products. The first type is decomposition. Where stuff breaks down. There is synthesis. I should double check I'm doing this in the same order. Yep. We're going to look at 2 that kind of look similar. There are single replacement and double replacement. Synthesis, if you have taken this at a different school, sometimes that's known as combination. So it's no difference. But we tend to use synthesis most of the time because you're making something. And then there's a very special type of double replacement reaction that gets its own category, because on planet Earth and for water-based life forms, as we are, that is the neutralization. Also sometimes just known plainly as the acid-base reaction. Because acids and bases in water play a huge part in its chemistry, and so it gets its own type. And then lastly, we're going to look at one type of combustion reaction, not combo. And specifically, the type of combustion that burns carbon-based things like fuel, oil, gasoline, all the stuff that makes fires become pretty and make a nice cleansing flame. You can have a combustion with reaction with a lot of different things, but we're not going to get that complex. But they're also known as oxidations. We're not going to get that complicated. You'll get a little bit into that in grade 12. So there's 6 different types of reactions. I'm going to go through what they look like. I've got a couple of demos for them, particularly for the first one. I should ask, however, is anybody not done writing that down before I quickly move on? So there's just the listing. First one, oops, not with the balancing. A review of your naming, which you've done so far. What is the name of that compound? Yeah. Sodium bicarbonate. So we've got sodium here, bicarbonate there. We didn't need Roman numerals. It's not often labeled like this on the package, but you will see it labeled as bicarbonate of soda. Soda is the old name for sodium. Bicarbonate of soda is baking soda. And it's this process in which it will break down at about 110 degrees Celsius in your oven. So this occurs there, you get sodium carbonate, water, and carbon dioxide. And carbon dioxide is what forms the bubbles in cakes and cookies. Sometimes in bread we'll use yeast to make that. There are types of bread where they use baking soda instead, but more often that type is a fermentation process. So it's a decomposition. People like it, and we've switched almost exclusively to baking soda because it doesn't have an awful smell, but it does leave sodium carbonate, which some people can taste, and there is a little bit of an extra weird salty flavor. We used to use an ammonium compound, and the ammonium compound would just reek like ammonia while you're cooking it, but it would entirely evaporate away and leave the bubbles behind and left nothing behind. Both the products turned into gas. But people don't like that one as much, but you'll find it in old recipes. So decomposition reactions have something going to other things. So you have something bigger breaking down into chunks. A compound is broken down into individual elements or smaller compounds. I have to put my shoes back on because I've got a demo for that. Over Halloween, I managed to capture the spirit of Halloween and put it in a bottle.
Bro, you know who's more locked in? Julian GG, bro. He's trying to get Ruby to play Brawl Stars with him.
Yeah. I'm already on 2 hours.
Okay, bro. How's that working out for you?
Megan accepted my friend list. Me and Megan are friends.
Oh, damn. Okay. Bro.
So it's just farming, bro. I do it in my lessons. It's 3 hours.
I gotta think about the lasting effect.
I don't like those apps, honestly.
Alright, Jaden.
No, well, I like some. I don't like Flora.
Alright, Jaden.
Alright. Thank you. Oh, shit.
Is it not enough this time?
Huh? What do you mean I'm not locked in?
Bro, both teams actually go.
What do you mean I'm not locked in, Zhao, bro? Have you seen how I've been cooking and
Do you have 2 sources yet?
Huh? Yes.
Fully ended.
Yes, fully annotated with notes.
How long do you stay up?
I didn't stay up. I'm just like that.
You're not. I know you stay up to midnight.
I did not stay up. Well, I did stay up, but I was reading like my own thing.
No, you were staying up to midnight sweating.
Why? I can do that shit in 2 hours. I did it in like an hour and
I
20
know you
minutes.
were.
Cap. Maybe you're just projecting.
No, I sleep at 10 p.m. every single night.
I sleep at 11, but that's not because of work.
Flexing bedtime.
That's it.
Damn, bro, you get sleep. That's
It's like
crazy.
that. It's like that. I wake up here. I wake up at 6. Because I cook breakfast.
What do you mean you cook breakfast?
Just cafe breakfast is so bad.
Bro, why would you cook breakfast?
It was easy. I have a half bowl machine maker.
Oh, what? Oh, bro, why do you eat hard boiled eggs?
I just cook a half bowl eggs and have kimchi and like. What?
Hmm? Oh, I thought he was behind me. I would have been so cooked.
Bro, I think you'd feel it was behind you.
What? What do you mean feel?
Feel the presence.
Hey, yo.
Like you'd be attracted, you know?
Huh?
Gravitational.
I think you're projecting, bro.
I didn't get you didn't get through. Aiden Suter got you. I mean,
If you want to skip more class, you should wait until he comes back.
but did he tell you about it? No, I haven't seen him, bro. I want to ask him. He didn't get that. He didn't touch
Oh, well, he's
Did he get anything?
yikes.
Not really.
Okay. You'll notice I covered the top in tinfoil. What you may not know is that Ghosts are soluble in water. I captured it and then managed to dissolve it into some water. At least that's my theory. Also, it has aluminum foil on it. Because have you ever seen people wearing aluminum foil on their heads?
Yeah.
That's to stop the ghosts from getting in, so I just
thought
figured
it was the
extra
radio waves.
protection. Well, that's what ghosts use. That's how you
So
kill
there's a
voices.
ghost in there?
Yeah, there's the ghost of Halloween. Pardon?
You think you can say hi?
Well, I'm gonna release the ghost of Halloween.
What type of ghost is it?
Well, we'll see when I let it out. Also, we don't want the ghost running around the classroom, so
No, you're gonna suck him up?
get a containment vessel,
No.
suck it away, aka Ghostbusters.
I thought those didn't work.
Oh, they work now.
Not a poor ghost, get arrested.
Gotta give it a minute to start up though. Baffle on.
Bring my boy ghost.
I should have turned it on right away.
I'm actually so wanted.
Okay.
Yeah, no, but like at the house, I just finish everything.
Well, why are your laptops open?
Yeah, Jao.
Actually, it's not a lot of time.
Both of your laptops are open.
Yeah, but mine is not lit.
Put them away in your bag. Close them entirely.
You're not lit, bro.
I'm not lit.
Yes, excellent.
That's crazy.
Okay, do we have
That's not fire.
flat Earth? What are you talking about?
Fire.
Yeah.
Fire is in like a metaphor for good or lit or
Fire?
yeah.
I actually put my water back.
Everything was okay
That's
until
so
the fire
fire,
reached
Mr.
attack.
Newfeld.
So
Mr. Newfeld, you're so fire.
It's right here.
I think I lost it. So.
Yo.
Okay, why are you standing in the back? What are you doing?
Because I don't want to pass it on.
No, come around. Yeah.
Put my water back.
You're good.
Put my water back.
Do you share water bottles?
Yeah.
I think microbiology needs to be on our next topic then. Like, oh my gosh. Okay. You will be. Okay, everybody ready? The ghost
Why didn't you tell me?
of Halloween release. Well, sometimes they're vengeful.
What? Celebrate.
Hello.
Oh, the ghost of Halloween is coming out. You should clap now. Yeah, very good. If I was to raise this, you can actually see it reacting below because I lied a little. It's not
Why is
it's
it
a
brown?
ghost.
Is it ghost
But
moving?
yeah, you notice it turned brown. I showed you a clear liquid. The clear liquid is what's breaking down. What I did, I'm waiting for everybody to stop talking. What I did is I hit a catalyst in here. So when I pulled off the stopper, the catalyst dropped down. The catalyst is potassium iodide. What is the name when you have a potential energy diagram of the large amount of energy you have to get over in order to make the reaction happen? Activation energy. So catalyst lowers the activation energy, so this reaction can happen at room temperature. And that reaction was hydrogen peroxide,
Wait. Isn't that deadly?
H2O2.
Isn't that deadly?
Well, yeah, especially that one, that's 30%. Becomes water and oxygen gas. Is it balanced? No, what do we do to balance it?
Double it.
Everything? That seems weird.
Oh, I thought on top. Or are we?
No, not the O2. Not the O2.
Not the O2.
No.
Okay.
Definitely.
Is that balanced out?
Yes.
Yeah, that works. We got 4 oxygens, we got 4 hydrogens, okay. So we have one type of thing breaking down into 2 things, or another way to put it, 2 molecules breaking down into 3 molecules. That is a decomposition, because we took a compound and we broke it down into more fundamental elements. Make sense? So this is AB going to A plus B. Did I miss anything down here? This is like we need the awkward demo now. People, no, right, for this one we don't need people who are dressed differently. Right here in front, come on up.
Come on, man.
Okay, I don't know if you know, but historically, the snowball was a dance, not a show. And so people go to the snowball, and obviously these two are married,
Yeah.
hold hands, dancing at the snowball, and then they look deeply into each other's eyes, and they are totally disgusted, and they walk away.
What?
Walk away, walk away. It's like a divorce.
Oh.
Or just, what do you call it in a dance when you're both totally disgusted with each other?
Disgust.
Disgust?
Yeah.
Just leaving?
Rejection.
There was an entire
Wow.
kerfuffle that happened in the houses because a particular person abandoned his snowball date. Please give them a hand for this awful and awkward demo. Don't worry, more awkward demos are coming, and you will be a part of them.
I couldn't see your eyes, Al.
Could you
It
ask?
looked like you guys
Yeah, I couldn't see your eyes.
So,
Yo, shut up.
Come on.
Friendly fire is crazy.
it's like a divorce.
Hey. Nothing like that.
Or, like this particular one, I look for awful examples. Apparently, a gentleman, well, I wouldn't call him a gentleman, waited until they were on a plane and they couldn't leave their seats to break up with his girlfriend.
Dang.
And then someone who's beside them live tweeted the whole thing.
How do you have Wi-Fi? Or did it not take out yet?
I have no idea. Ooh.
Wi-Fi on plane.
I don't want to go to X. Don't go to X. Don't go to X.
That looks like economy. They shouldn't have Wi-Fi.
How dare they have? The poors should not have Wi-Fi.
No, you can still get Wi-Fi here.
Well,
Yeah, you
unlike
can.
Porter.
No, it depends on the airline.
Okay, next one. Synthesis.
Really?
Hmm.
Ooh.
I have to be careful that I don't use people who I'm going to need for the later ones. So it'll be red, red. We did two at the front, so why don't we do the two at the back? Yeah. Come. Synthesis reactions. One of them, you could have H2 plus O2 goes to H2O. So come on up. Now you're standing far apart. They are at the snowball dance, as it occurred 20 years ago. Dancing, I get to dance now. And their dates have abandoned them, but they look across the room, lock eyes, and fall deeply in love. Immediately they come together and start dancing.
Start dancing.
And now
Full on
obviously
dancing.
they are married. Please give them a hand for this awkward demonstration.
Oh.
That's like the plot of like a Colleen Hoover book or something.
This is like a marriage.
If you know, you know.
How many reactions are there?
Well, I haven't read one myself, but I've seen it. Icebreaker type.
It's like a marriage.
Bro, he's farming. Let him farm. Fandango. Why does he look like a werewolf?
Yo, you can't say that, bro.
Do you too know the concept?
Marriage. Marriage is what brings us together.
I won't show any more because it doesn't make any sense even now in context. But if you haven't seen The Princess Bride, I highly recommend you go see it. You're incredibly lucky if you haven't seen it because now you get to. It is a marriage where things come together. So you should get separate things coming together to make a larger thing. Most of the ones I ask you to do will be things where you see, two things making one larger things, but you can also have synthesis reactions like this. CO2 plus H2O, one of the most famous reactions in the world and responsible for feeding all life on Earth. What does it make?
Photosynthesis.
Photosynthesis. What does it make?
Glucose.
Glucose. You probably love sucrose. Glucose actually doesn't taste very nice. It's not super sweet. And you tend to only find it when it's bound to something else. Sucrose is an example of table sugar in which it's a dimer of two different sugars, and most people do like the taste of that. That's incredibly sweet. So this is a synthesis. If you balanced it, you end up with 12 things that make 7 things. Oxygen is a byproduct, but you have made this giant molecule that then becomes fiber or sugar or whatever the plant needs in that particular moment. It's used structurally, it's used for food, it's used for lots of things. Does yours goes off the page like mine does here? Yeah, no? Okay. Combination synthesis reactions involve 2 elements or small compounds that react together to produce I should put, larger compound. So, synthesis reactions. We will tend to see A plus B goes to AB. So it's the opposite of decomposition. We already did this one. Does anyone remember what reaction that was? That was in the balloon where I added hydrogen and oxygen gas and it went bang really loudly. That was the synthesis reaction. It is an exothermic reaction and quite loud. This reaction is endothermic, so they can differ in terms of their energy requirements. Single replacement. Now for this one, I've got to be a little bit more careful. Does anybody else have a red color? You have red on you. Very bad. So you two. Excellent. And then we need no red what's. You've got some red on the shoulder. I like how you're covering it completely up. So that's perfect because you're completely different because you're wearing an illegal hoodie. So excellent. Well done. Now you two then, because I'm going with the red here, you're both the same. Okay? So you can't be together. You two are joined.
What?
Yeah, joined. Dancing at the dance. You have to dance.
Yay.
Excellent. Now, here's the skill testing question. You're going to replace one of them. You have to replace the correct one. So, like replaces like. Okay, go. Do it. Yeah,
You,
go.
like, take
Replace,
one.
kick the other one out. Yeah. Who?
Kevin. Okay.
Kick him out. Okay, Kevin, you walk. No, walk away. Walk away. And look sad. Look a little sad. Excellent. Now, no, you pay attention. Married again.
Oh.
Join. No, you two joined. Yeah, this is so complicated. Now dancing.
They're more at eye level.
Single replacement. An element came in and replaced a like element. And the other one just got kicked away. Please give them a hand. What do you mean what happens? Well, that's just sad and lonely for the rest of his life. Yeah.
I don't know, bro. I learned to single replacement.
So,
Listen, you.
1 second. Which is iron going to kick out? Is it going to kick out the
It's kicking out
copper, or is it not calling out? Or is it going to kick out the sulfate? Since you were involved, I will let you go deep. It's going to kick out the copper. Because what is iron? And what's copper? Metal. So metal replaces metal. So that kicks it out. And we get Fe SO4 plus copper. Solid. This would have been iron solid.
Can you write it both ways? Can you put copper before?
Yeah, it's A plus B equals B plus A. It doesn't, like math, it doesn't matter.
Mr. New.
Yep.
Would this be the same as a displacement reaction?
Replacement and displacement, if you learned it that way, are exactly the same.
Okay.
2 different words. So yeah, some places teach it at, did you say displacement? Because I've heard it, yeah. So some people do it as a displacement. If you're writing, it doesn't matter which one you do, they're both correct. but I'll probably use replacement because that's in the BC curriculum language. One we've already done in class is you were given aluminum foil and copper chloride. And then what did you get out of it? It got really hot. What would be the products? Aluminum chloride, although we need the numbers, so I haven't put any numbers below. And what would be left over? Copper. So we would definitely get copper solid. That came out as brown gunk. What would this compound be? AlCl2, AlCl, Al2Cl, Al3Cl, AlCl3, AlCl2? Why? It does have a nice mirroring function there. Unfortunately, that won't be true.
Yeah.
It did work here, but it didn't work there.
What's the charge of aluminum in this case?
What's the charge of aluminum?
3 plus, right?
3 plus.
So it'd be AlCl3.
AlCl3. So when you do the numbers, they're not related to the numbers ahead. Those numbers are from the charges. These numbers will be from the charges. The reason this worked is because this is copper 2, and it does in fact make iron 2. So they just happen to have the same charge, so you don't change it. If it was iron 3, it would be Fe2 bracket SO43, and you get a little bit more complicated response. This one helps if you think of water not as H2O, but as hydrogen hydroxide.
Oh.
Ha. Ha. Yes?
Wait, does the copper just like melt away then?
No, it comes out as a powder, like a solid in there. When you did the reaction, all that brown gunk you made, that was copper solid. If you took it out, like filtered it out, rinsed it, and then melted it, you'd have a chunk of copper. Probably be worth a couple bucks. Using that, what would K plus Ho make?
I'm assuming it replaces H.
Yep. Go.
Does it replace H?
Yeah, so what would it make?
I did 2H2 plus 2K2O.
Say that again, what does it make?
2H2.
Don't balance it.
Oh,
H2,
H2 plus KO.
KO.
Or K2.
Oh, K2O. If you wrote that, that's a reasonable assumption. You would say, oh, it's taken away both the H's. I mean, under certain conditions, that might be possible. It's not the most likely, but at a grade 10 level, it's okay. It's more likely to be H2 plus KOH. It only kicks out one of the hydrogens. The other one, and that makes a hydroxide, which is quite stable. And so the hydroxide then is an ionic compound, matches with the potassium, and you make potassium hydroxide. In both cases, though, you make hydrogen gas. If you wrote either one of these as a prediction, because I asked you to predict, they'd both be reasonable. In most cases, when I ask you, what I'm asking for is, first of all, you need to get the charges right, and then what's the most reasonable thing? Metals, kick out metals. I haven't shown you one with a non-metal. I might as well do that next. The overall reaction, you have, say, AB plus C, so you have some sort of compound and an element, and you get another compound, let's say AC plus B. If I had, Given who's been recently, I think, promoted to the health services in the States, he's very anti-fluoride in toothpaste because it's a conspiracy theory and has long been a conspiracy theory since the 50s. It was said that the Russians were putting fluoride in our water for all sorts of reasons. Calcium chloride plus fluoride, using the same logic, what would be our product? By hand. Yep. Oh, you went like this, so it was like an auction.
Maybe FCl.
Which one, now, F is most like which one, calcium or Cl? Cl. So that'll be the one it kicks out. So you'll most likely get Ca F plus chlorine. And chlorine as a gas, just like F, always dances in pairs. What's the charge in calcium? Do you have your data table? Everybody should have their data table up. Oh, wait, you don't call it. Let the man look. Let the man look. Two.
You're such an fool.
And what is F?
One,
One, so what would the final compound be?
CA2,
If you've got two there, minus one there,
CAF.
CaF2. Because you need two of those to balance out the charges. This is why there's fluoride in your toothpaste. A lot of the calcium in your teeth is a calcium chloride compound. And if you put in fluoride, it replaces the chlorine with fluoride. The calcium fluoride ionic bond is stronger than the calcium chloride ionic bond. And that means the bacteria can't break it down as quickly, and it literally prevents them from eating your teeth away. So it prevents cavities by putting in a stronger bond that the bacteria don't have a means of breaking down. They can very slowly, which is why you still have to brush your teeth, even if it's fluoridated. But it takes them a lot longer, and they're more likely to catch it earlier and make sure you're brushing your teeth properly. Without that, we wouldn't have teeth. You could ask your grandparents. There was a time, not that long ago, like 40s and 50s, a common wedding gift was to give them a complete set of false teeth. So you would pay for someone to go to the dentist and rip out all of their teeth and then put in false teeth right away. Because they're eventually going to fall out anyway. So you might as well get it all done at once at the beginning of your marriage as a wedding gift, and then just have false teeth for the rest of your life. And then shortly after that, fluoride was invented, and then everybody who did that felt really dumb. Yep.
You told us this before.
Oh, did I? Well, it's related to that. Sorry. It's such a good start. Anyway, at a dance, this is, oh, did we? Yeah, we did. This is like cutting in. I apparently once told the same story. I may have already said this. 6 times in 1 week, a student counted and kept a record of the times. The student may have been one of my own children, and I disowned him. Good? Okay, go through these. I'm going to call people up to identify them. You have, what, 3 minutes? 4 minutes? Designate these as either synthesis, single replacement, or decomposition. Take a look at the reactions, see which type they fit.
Okay, so this
Oh, and I'll go get the next demo.
That's his divorce marriage.
And
This is the
shut off the snow. Oh, I forgot to mention this at the beginning of class. This is important. We are going until we're done this because we have a thing going. So we may go past 1 o'clock. It depends how fast we go. Just to put a little speed on that.
Yeah. Big dumb job.
Would you get like what each time you do? So what I do, like composition,
You don't love this.
if you want the Evo, yeah, this is on the Evo. So this is the classic like sound stroke for one.
I'm not even like Evo.
It hatches crap. But this is only for decomposition.
You
It's
caught
not
four
for
there.
because there's one at the start,
I caught
and
two,
two.
and you caught one as well.
I did not, but
Yes,
this
you
is
did.
last
Last
time.
time.
So I did not.
Last time we did.
You
caught one.
Actually, yeah, I should say this is only good for one more.
I think I was good. I
So
don't know.
this
That's
is
because you caught one and like you know
No.
pissed me off.
What? No idea.
You remember what
I was angry, bro.
No,
Do you not
no.
remember the last time we guys had that race? I was like, yeah, we should have raised it a lot. That's what I was saying. Do you not remember my screen? Yeah. That was a tough one. If you raised it, do you not remember the point last year? It was the rate and we just so from the we could still beat.
I would hit on it.
There are, ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in total. How many can you see? 1, 2, 3, 4, 5, 6. So I'll start off with 7.
I can feel the imbalance in the legs. I could feel
And
the imbalance.
who's here? Alex? He left. Buddy's here. Aria is here. Ariel. Charlie's not here. Does anybody know when Charlie's getting back? Woo. Not here. Katie's now back. Natsuho's Jaden is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hold it. We're missing 2 more people. No. Who? Okay. Coming up when I call your name. There are 2 pens, only 2 people at a time. I'm going to call 7. First come, first serve. Identify them.
Wow.
We are Aria, Tyler, Isaac, Natsuho, Ariel, Sterling, and Guy. What have you just done?
It was Isaac. I don't know what he was doing.
Isaac, stop doing that.
This is what I'm
That was
saying.
not me.
I'm 2. Yeah, you're not 1, dude.
What am I?
You can 2 people can write at the same time. It's in first come first serve. You can do any one you like.
Oh, okay. Yes.
Just pass on the pen.
Thank you. Can I do 2?
Sure, if you let me do this.
Oh, I think that there's another. Oh.
Are you gonna do that one?
I know someone who
And now,
appreciates your effort every day.
Need 2 more.
Kiona,
Yeah, but someone
that's the other one we're missing.
if you know, you know.
See who? Again.
I didn't show you my English.
Oh.
And Jessica.
What was it? I already knew this. What was it? PH and then PH Jason.
Oh, the other one's down there.
Yeah, because
Intense Kiona's missing. Who else am I missing? Okay. Who was sitting there? Okay, no, I got Katie. Oh, just click on the side somewhere. There you go.
That is good. And you bumped it again.
Good. Go through and double check. We have a pair, and an element. A pair and an element going to an element. So AB plus C. Going to a pair and an element, that is single replacement. You have one thing going to 2 things, that's a decomposition. 2 things going to 1 thing is a synthesis. 1 thing going to multiple 2 things is a decomposition. 2 things going to 1 thing is a synthesis. A pair and an element going to a pair and an element, single replacement. An element and a pair going to an element and a pair, single replacement. 2 types of things going to 1 thing, or another way of saying it is 13 things going to 8 things. We've made sulfur trioxide. Synthesis, decomposition, yes, because 1 thing going to 2 things, 2 things going to 1 thing is another synthesis. Good. Okay, next one, double replacement. This one needs another demo. Now I need pairs.
I'll go find Forrest.
I think there, because you have
Are we-
identical shirt.
Are we renewing our annulments?
And then
Wait, that's wrong.
I need
We're renewing our
another.
annulments. Yeah, that's correct.
I could go weird jacket. Weird jacket. Excellent. Yes. Come on. Okay. Very similar to a single replacement, but like replaces like. Now, currently you're with the wrong pairs. So you have to join up with your opposite. Hello. Okay. Now separate. Come over here so we can clearly see what's going on at the dance. Now they're each.
I think I might consider that.
Consider what?
That split chain was not.
I didn't say anything.
Why are you still talking?
I'm sure.
Excellent. Dancing. Dancing. They look across the room, and here's the skill testing part. I want you to switch partners correctly. Go.
Oh, wait, are we partners?
That would be that would be incorrectly.
Okay.
Like replaces like, so now they have different partners. The other one can work, but it's not a double replacement reaction. That's an entirely different type of reaction. In this one, we have two. It's always an ionic, and then they switch partners. So cations switch the anions, or vice versa, depending on how you want to think about it. And when I say correctly, I have had it where both of them walk across, and they end up with the same partner. And obviously, that doesn't work either. Please give them a hand for that awkward demo.
You did great, Michael.
So, metal.
Worthy.
I might move you. Over there.
Oh my god, segregated.
Calcium replaces sodium. So you get calcium chloride and sodium nitrate. Notice once again. And maybe if you went to the very back. There we go. That might work out a little better. Excellent. Okay. Eyes back up here. It's sodium chloride, but calcium chloride, it's CaCl2 versus NaCl. Again, why does this have 2 and that only has 1? Charges. This is +1. This is +2. The number you have is based on the charge, not what was there beforehand. They change depending on who their partner is. So in every case, if you have AB plus CD, who is going to be A's partner? D. So you get AD. And what will the other product be? BC or CB? It would have to be CB because that is the metal, and that is the non-metal. Question? Maybe if you two were a little further.
I don't like him, man.
Yeah, okay. He doesn't even like her. He doesn't like her. Yeah. Oh, that's a D. Yeah, that's called messy writing. No. What are you doing? You're there because you. Put it back down. I'm not talking to you right now, so put it back down. Excellent. Two compounds react and switch partners. I used to say this is like cutting in a dance, and apparently that reference was too dated. So I was told by someone from Alberta, this is like line dancing. Because you switch your partners at some point, doing something like the do-si-do. I'm not entirely sure. So if you're from Alberta, can you confirm? Does dancing like that occur? Excellent, excellent. So this is like line dancing. You switch your partners, and then everybody ends up with someone else. Or like a very interesting night out. Now I have a reaction. I have Ki plus PbNO3. So potassium iodide and lead nitrate. I would like you to predict the two possible products. And I only brought half the demo, which makes that a little bit more difficult.
Well, you guys are like the same distance apart as you were just now.
Yeah, it's just by one
Yeah,
dance.
what is the point of both of you moving?
What?
Jaden and
I don't know.
you guys are the
Ask
same
Mr.
distance
Neufeld.
apart.
Ask Mr. Neufeld. It's his decision.
In fact, you're further away from me.
Oh.
I feel like Pluto, bro. I'm segregated from everyone.
What do you mean, bro? I feel like Pluto.
Shut up, Isaac.
That might be better. Wait, who drew that?
What are you doing?
I was just moving farther from him.
That seems odd, but okay, I'll.
Go.
Okay, this is the potassium iodide. It is as you can tell, a clear liquid. A little bit more. And some lead nitrate. Lead nitrate obviously would be poisonous. Why? Leave the lead part. And so I've got the lead nitrate and the potassium iodide, and when I mix it together, we make a very brilliant yellow. This yellow has been used to decorate Big Bird in a toy that had to be recalled because they painted it. Lead paint used to be a very popular paint. Lead is a wonderful metal to have to bind to make a color because it's very resistant to fading. It's just that it's a little poisonous. And so when they paint it on Big Bird, which is a children's toy, and when children chew on the toy, then they get lead poisoning. I'm assuming, anybody here not seen Toy Story? Couple people. Watch Toy Story, you're also so lucky you get to see that. Have I done the story about what happened to Sid?
No.
If you look at Sid, the crazy kid next door who makes weird things and everybody's like, oh, he's a mean kid. If you look at his window, they walk on, they get trapped in this house. His window has a very particular cracking pattern in the paint, long rectangular strips. That is a classic sign of lead paint, and it's all peeling off. It's in his room, it's in his floor. Sid isn't maladjusted. Sid is suffering from very obvious lead poisoning. Inability to pay attention, difficulty controlling his temper are all classic symptoms of lead poisoning. So it's not that Sid is a bad person, it's that Sid is living in a really rough environment and he's getting poisoned. He has an environmental cause. The fact he takes it out on other people you may say it doesn't make a difference, but there is a cause for that, and it's kind of neat that it's reflected in the movie. So yeah, wonderful yellow one. There's only two possibilities that it could be. I've said it's the lead compound, so what lead compound did we make? If we switch the partners, what is it? PBI. Is it PBI? Or PBI2 or PBI3 or PB2I? PBI2. What is the charge of PB here? 2 plus. So therefore it must be plus 2 here. Iodine's minus, so that looks good. What would be the other compound? KNO3. K is plus 1, NO3 is minus 1, so at this point this just becomes a balancing problem. 2, got 2 there, put 2 there, we're probably fine. That's the one that made the yellow color, so this came out as a solid. This remained in solution, that's aqueous. These were both aqueous, and before they reacted, they're also clear. So you don't see that nice yellow color until after it reacts and the lead combines with the iodine. Lead does make a wonderful white paint, yellow paint. There's some good red ones. We don't use them anymore quite as often because of the toxicity we finally learned. It has been said that the rise and then eventual fall of violence in societies can be tracked with the half-life of leaded gasoline in the environment. Yes? Does it matter which one of these comes first? Yeah, no. Plus sign. PBI2, I mean, you could write this 2KNO3 plus PBI2 because A plus B equals B plus A. If you have a plus sign, doesn't matter which order it is on either side of the plus sign. Any other questions? Okay. Next one, the very special type of, now I want to do this one as a lab after our cross grade, so I'm going to save some of the notes for later for this section, but in terms of recognizing it, you will always see a hydrogen compound of some kind. Usually the hydrogen will be in front unless it's acetic acid. You will always have a hydroxide. So a hydroxide is base and H plus is acid, but it's usually bound to something, so some sort of acid and then some sort of base. They combine to make H, and then what's left over makes the salt. A salt is defined as the product of an acid-base reaction, the leftover metal and non-metal. So table salt is just one example of salt, particularly the example from NaOH plus HCl. You get NaCl, that's table salt. But if you use literally any other compound, in this case, sodium sulfate is a type of salt. Table salt is just an edible one. Potassium, sodium chloride, you can buy potassium chloride. It's called no salt. It tastes not good, but if you use a very small amount of it, you can pretend it's salt. These are often exothermic, but I have to really put the emphasis on usual. There are exceptions. If I give you one of these to identify and you say it's double replacement, that is technically incorrect because we do recognize this one as separate, because on planet Earth, acid-base chemistry is so important, we want to view it as separate and different. We're going to skip those because I want to do that later as a lab. But for these ones, what I would like you to do is just go through, first step, is this an acid base? Yes or no? So, is it neutralization? If it's not a neutralization, the second step would be, if you can, tell me, is it a synthesis, single replacement, double replacement, decomposition? But the first question is just, is it acid-base, just to get you used looking for the H and the OH, and then it makes a water and salt. Actually, we're making fairly good. We might get it done before 1. Oh, I did keep one of the test tubes from earlier, so you can see what I made is precipitate. It is a solid that appeared in there. And you can tell because it's all now gone to the bottom. This test tube was laying on the side, which is why there's some here. But lead iodine is a solid. So you paint that on with a solvent of some kind and paint. The solvent evaporates away and you're left with this coating of lead iodine. Made famous in the Simpsons cartoon because when there was a nuclear bomb, their house supposedly had so much lead paint on it, they were fine. How many we got? Ooh, we can do all those. 1, 2, 3, 4, 5, 6. Actually, yes, no could be confused with neutralization, so let's not do that. Yes or no. It is a neutralization or it isn't. 1, 2, 3, 4, 5, 6. You don't have to identify the type of reaction. Just check mark or put a cross if it's not, whether it is a neutralization. I'm going to call up 6 people. Katie. Alexander. Jaden. Isabel.
Where's the pen? Where's the other one?
Wait,
Isaac.
which one do you want me to do?
Anyone.
Oh.
And 2 can go at the same time. Here's the second pet. Oh, and now your question made me forget how many people I've called up. 1, 2, 3, 4, 5. So I need one more.
Acid-base reaction.
Oh, Alexander, you're doing 2.
I'm so good. Is there an S here?
What?
What? It's synthesis.
Oh yeah, but I thought. Are we
Yeah,
just
yeah, he's confused. You can do what you like.
Just do. Yeah. Wait. Do I? Oh, I need to do this.
So you need to do those 2. You need to do that one. Apparently, I called too many people up. Excellent. Okay. Pardon? Always can. As long as you go in the washroom, you don't have to ask. Identifying a neutralization. So lots of them are not. This one was identified. It was. What you're looking for is H. OH makes water. And then you should see the salt pair up. So acid plus base, H and OH make water, and then the 2 parts of the salt compare on the other side. So if you see that pattern, particularly the H and OH, you know you've got an acid-base reaction. Someone put ABR, and I don't know what that means.
Acid-base reaction.
Oh, that is an acid-base reaction. Okay. So you can see that here. We have H. H. H, OH, making water. We have our metal and our non-metal making a salt. Now I didn't ask right away, but everybody started doing it anyway. This is a synthesis reaction, so you have 2 things going to 1 thing. This person did it correctly. They were just supposed to say it's not an acid base. It's not. It does have an acid though, but it actually has an acid on both sides. So it's a little weird. What type of reaction is this? It would be a weird type of double replacement, yeah, with H's. It's also, taking a look at it, an impossible one. You'll learn that in grade 12. That reaction actually can't happen. This, again, it does make water, so that sometimes fools some people, and it does have acid, but it doesn't have the extra partner for the OH. What type of reaction is this? Deconstruction? Close. Decomposition. Did you say deposition?
Yep, my bad.
That's a lawyer thing. But deconstruction often happens in a deposition. There you go. Last type of reaction, and that is my favorite one to demo because of the purity. Let's see, do I have it? watch everything go up in a cleansing flame.
Oh, he's burning stuff.
Oh.
Well, yeah, it's a combustion reaction. Combustion reactions always have the same input. It takes in oxygen, and you give off what? Carbon dioxide and water. What do you mean why? Because the flames look so pretty. If you listen closely, they tell you things. I won't do those things, but I do. What? Yeah, it was perfect to burn.
It sure was.
Do it again. Let's burn some butts.
Woohoo! Oh, is it going out? What I really do find interesting, if you look in here afterwards, you can still read it in the ash. The ink doesn't burn. There's lots of metal in the ink, and so it's still there and readable in the ash. There have been cases where people have tried to burn evidence, but they didn't bother to stir the ashes afterwards. They left, and parts of pages were left out that were still readable. The police took pictures and were still able to retrieve some of the notes that were tried, even though it was fully burnt. Depends on the ink, of course. But this is a combustion. And this, all combustions have in common. You have an oxygen, you give off water, and you give off CO2. Any CH or CHO compound can work. The most common one being where does this reaction happen? This happens in mitochondria. So the mitochondria take oxygen, they burn it, so you are literally a combustion engine. You give off H2O and CO2. There are combustions that add in sulfur and nitrogen, and then you get sulfur oxide gases of a variety of type, SO2, SO3, SO4, and nitrogen gases, NO2, NO3, N2O4 would be common. But we're not going to do any of those. As complicated as we'll get is carbon, hydrogen, and oxygen giving off H2O and CO2. So these will be a constant, and that will be a constant. So they're fairly easy to identify in that way. They can kind of look like some sort of double replacement if you squint your eyes, so it is important to make sure you're not getting them mixed up with those. That is all 6 that you need to know. And we are in time for lunch. I do have a worksheet to start.
It smells like it's still burning.
So, congratulations, we were actually 10 minutes faster than the other class. So you get to go for your lunch. What about it?
It's not funny if you keep laughing at his time. He just said something.
But before you go,
It was a funny joke.
did I not hold it? Did I hold your table? Didn't I give you the drink?
They're good drums.
Aha. Don't go just yet. I just realized one more thing before you go. Sit back down. Sit. Are you sitting comfortably?